Question 18. Find the Maclaurin series of the following functions in sigma notation. Okay, well, although this Maclaurin series formula, which is like f of x is equal to f of 0 plus f prime of 0 over 1 factorial x plus f double prime of 0 over 2 factorial of x squared, and so on and so on. This formula is available. It really is hard to use. So when you're asked to find the Maclaurin series of these things, you should try to make use of previously known formulas. And actually, although this one's given, you should really remember this as a over 1 minus r being a plus ar, the geometric series formula. Okay? Alright, so let me show you how the first one is done. You have log of x plus 1, but then this itself is hard to figure out, whereas if you differentiate this, this is 1 over x plus 1, or you can also think about this as 1 over 1 minus x, right? 1 plus x. And if you see that the derivative log of x plus 1 is 1 over 1 plus x, then that's really similar to this one. The only difference is here I have plus x, whereas this one is negative x. So what you want to do is you want to use this formula. You want to think this as 1 over 1 minus negative x, and think of this as this formula here with, instead of x I have negative x, right? So you should write sigma n equals to 0 to infinity of negative x to the nth power, which is same as sigma n equals to 0 to infinity of negative 1 to the nth power times x to the n. Now that we have figured out the Maclaurin series of the derivative, how do we recover the Maclaurin series of the original one? Well, that will be just simply integrating what you have here. So if we integrate then it will be the x to the n will be integrated using the power rule. You add 1 to the exponent and put the reciprocal. Then sigma n from 0 to infinity. Now there's just one more thing you should do. It's that really there's plus c, and c will be the constant term, and the c here will be same as f of 0. But what is f of 0? Log of x, when you plug in 0 here, log of 1 is 0, so this actually ends up being equal to 0, so you only have this much. So this will be the answer. Okay, next question. Now, since you have sine of 3x, and I know that sine of x is this, let's see what this means for sine of 3x. That means simply you're replacing the x by 3x, and then one of the things that you have to do is that you have to separate the coefficient, the constant multiple, and the variable's power. So the power has to be separated from the coefficient, because really coefficient would be this, all this would be the coefficient of the power series. And often it's important that you know the coefficient of the Maclaurin series. So you have to write it like this, and then since you have just x multiplied, what does that mean? X times sine 3x would mean x times sigma n equals to 0 to infinity of negative 1 to the n, 2n plus 1 factorial, and 3 to the 2n plus 1, x to the 2n plus 1. Now since x is multiplied with this, when this goes inside the sigma, you have x to the first power times x to the 2n plus 1, and because of the exponential rule, the exponents add up, and you finally end up with sigma n equals to 0 to infinity of negative 1 to the nth power over 2n plus 1 factorial, and 3 to the 2n plus 1 here, and then this will be x to the 2n plus 2. C. Now I know that e to the 2x would be using this one here, so that sigma n equals to 0 through n equals to infinity 1 over n factorial. 2x is replacing x, right? So since e to the x is this, and now you want to replace x by 2x, you want to replace x by 2x like this. When you do this, make sure you don't forget this parenthesis. It's very important. You're going to get a wrong answer if you forget that parenthesis. 2 to the n times x to the n. And then, by the same way, if this was 3 instead of 2, you would be getting sigma n from 0 to infinity of 1 over n factorial 3 to the n x to the n. Okay. Now, what does that mean if I have e to the 2x plus 2 e to the 3x? That would mean I have sigma n equals to 0, and these two are being added, right? With this times 2. Twice of this with this times 2. This times 2. So you're going to get 2 to the n over n factorial x to the n plus 2 times 3 to the n over n factorial x to the n. And since they both have x to the n and n factorial down there, you should rewrite the solution as 2 to the n plus 2 times 3 to the n over n factorial. And always try to, you should always put the numbers that don't have the x's in there separate from the x itself, because you have to write it in power series. Always that should be some constant times x to the n. So that's the answer. D here, we just did, this is very similar to 1 over 1 minus x, so we should do 1 over 1 plus x squared equal to 1 over 1 minus negative x squared, which would be using this one here, except that instead of x, I'll be using negative x squared to the nth power. And then that would be negative 1 to the nth power x squared to the nth power, so that's x to the 2n. Okay. Now, this next question, arctan, there's actually a relationship between this arctangent and 1 plus x squared. What is it? The relationship is that the integral of this would be arctangent. The derivative of the arctangent is 1 over 1 plus x squared. So if you integrate this, you're going to get arctangent. So we can actually solve E right away by saying that arctan of x is the integral of this, which is, well, if you integrate it, you first add 1 to the exponent and put the reciprocal in front. So that will be your arctangent. Actually, there should be a plus c there, but because arctangent of 0 is 0, and that means that c would be also 0. You have to be careful because sometimes, like if you want to get cosine out of sine by integrating sine, integrating negative sine, then because cosine of 0 is 1, you really need that plus c, and c should equal to 1. So there is a case where you really need that, but in this case you wouldn't need it. Okay. F. For this question, well, this one, it's a little hard to think, but if you have 1 over 1 minus x, and if you differentiate it, this is same as, let's see, this is 1 minus x to the negative 1, and you're differentiating this, and then negative 1 comes forward, you have to subtract the 1, and then you have to use the chain rule, so the derivative of the inside function will be there. So negative negative cancels, and you end up with 1 over 1 minus x squared. And that's actually pretty important, because see, if you have 1 over 1 minus x prime, then it gives you that, which means I can differentiate this, and that's going to be the series for 1 over 1 minus x squared. And that's not much different than what we were given, 1 over 1 plus x squared, because 1 over 1 plus x, there's just this plus and minus. That's the only difference. So once we have this, we can modify the answer to get an answer for this. So let's try that. We have 1 over 1 minus x squared equals to 1 over 1 minus x prime, which is now equal to the derivative of this function, nx to the n minus 1. And now we have the series for this. Now what you need to do is 1 over 1 plus x squared is 1 over 1 minus negative x squared, and therefore we can use this with x replaced by negative x, which is n times negative x, n minus 1. And then finally you separate out the negative 1 to the n minus 1 with x to the n minus 1, and that's it. That's the Taylor series of that last one. Okay. Find the interval of convergence and radius of convergence of the following power series. Alright, so we always use ratio test for interval of convergence, radius of convergence. So we just copy this down here. Negative 1 to the n, 3 to the n plus 1, 2 to the n plus n. That's a lot of writing, but you have to do it. And then over on the top, just replace all the n that you wrote down by n plus 1. 3 to the n plus 1 over 2 to the n plus 1 plus n plus 1. And this will be x plus 2 to the n plus 1. Okay, so these two are easiest. X plus 2 to the n will cancel away, leaving x plus 2. Negative 1 to the n plus 1 and negative 1 to the n will cancel away, leaving a negative 1. And the remaining this over this over this over that, you just multiply the inside and outside. The outside multiplies to the top, so you get 3 to the n plus 1 times 2 to the n plus n over 3 to the n plus 1 times 2 to the n plus 1, and then plus n plus 1. Okay, we still need the limit n going to infinity. Okay. So at this point, it's really hard to figure out which is going to which, but these two are comparable and these two are comparable, right? You can even say already right here that since 3 to the n plus 1 is dominating 1, so if you had this, it's just 3 to the n versus 3 to the n plus 1, because plus 1 doesn't do anything. And same thing over here, this is 2 to the n versus 2 to the n plus 1, because these are being dominated by these other terms. Okay, so that's going to give you negative 1, 3 to the n plus 1 divided by 3 to the n, 2 to the n divided by 2 to the n plus 1, limit n going to infinity, x plus 2 is still there, which will be 3 to the n plus 1 divided by 3 to the n will be just 3. And this one, this is more, so this is 1 over 2 x plus 2. Now we need this to be less than 1, so if we take the absolute value of r, it has to be less than 1, so that means when you take absolute value of 3 over 2, absolute value gets rid of negative 1, and then x plus 2, that's less than 1, and if you multiply 2/3 both sides, then you get x plus 2 absolute value less than 2/3. And this basically means that if you do x minus negative 2 absolute value less than 2/3, if you view it like this, this means that x is at most 2/3 away from this point negative 2. So negative 2 is like the center of the interval, and 2/3 is the radius of convergence, because that's the radius of the interval. You can view it like this, but since this is a little technical, let's just solve this. Well, what does this mean? This means that x plus 2 would be between 2/3 and negative 2/3. Just remember, whenever you take away the absolute value, it's between the positive one and the negative of that value. So that if you subtract 2, you're going to get 2/3 minus 2 is negative 4/3, whereas 2/3 minus 2 will be negative, let's see, 6 over 3 is 2, so it'll be negative 8/3. So that's basically the interval. And what's the half of this? Well, the distance between these two is like negative 4 over 3 minus negative 8 over 3. If you subtract them, you get the distance, and if you divide by 2, you're going to get 4 over 3 divided by, so you're going to get 2/3 if you do it this way too. So either way, you're going to see that the radius of convergence is 2/3. Now, what you have is not all, because now you need to find the interval of convergence. And for interval of convergence, you need to figure out what's happening at the endpoints. See, the endpoints here are these 2 points, negative 4/3 and negative 8/3. So let's see what happens at those points. First, when x is equals to negative 4/3, that's going to be sigma n from 0 to infinity, negative 1 to the nth power 3 to the n plus 1 over 2 to the n plus 1, n plus n. And when this is negative 4/3, this will be 6 over 3 minus 4/3, so that's 2 over 3 to the nth power. Okay? And then I think what's happening here is that if you look at this, when n is really big, this is like 3 over 2 to the nth power, because these are ignored when n is really big. And this is 2 over 3 to the nth power, so they cancel to give you 1. So that means that this limit is not going to go to 0, it's going to go to 1. So by the test for divergence, it's going to give you something that does not go to 0. So if I say limit n going to infinity 3 to the n plus 1 over 2 to the n plus n, 2/3 of n, that's same as 3 to the n plus 1. No, sorry, adding, you're not adding 1 to the exponent, so you're adding 1 to the denominator. No, to, not the denominator. You're adding 1 to 3 to the n. And then 3 to the n should be paired with these two, times you have 2 to the n on top, whereas down here you have 2 to the n plus n on the bottom. So when you take the limit, these dominating terms and these two dominating terms, they're just both equal to 1, so it's equal to 1, which is not equal to 0. Therefore, by test for divergence, you're going to get divergence at negative 4/3. Okay, so diverges because of test for divergence, nth term test for divergence. And then for x equals to negative 8/3, you're going to see that this will be negative 2/3. Okay, so if you replace x by negative 8/3 and simplify here, you're going to get negative 2/3. And it's the same story. You get negative 1 to the nth power, negative 1 to the nth power. So these two cancel away. And then what you're left with is something that diverges for the same reason. So again, diverges because of the test for divergence. Therefore, the conclusion is that none of the endpoints do give you convergence. So the answer is interval of convergence is negative 8/3 to negative 4/3, where the endpoints are not included, so we're using this open bracket. Okay, find the first three non-zero terms of the Taylor series for sine 2x expanded at pi/8. This one, you really need the formula, which is that f of x is f of a plus f prime of a over 1 factorial x minus a, and then f double prime of a over 2 factorial x minus a squared, and so on and so on. Now, since it says first three non-zero terms, hopefully none of these are zero, and we will just use this. Okay, so for our case, we need f prime, and f double prime. So let's do that. F is given as sine 2x. F prime of x is 2 cosine 2x. F double prime of x would be negative 4 sine 2x. See, the appearance of these two is because of the chain rule, and because another chain rule is applied here, 2 now becomes multiplied by 2 again to get 4. And the derivative of cosine is negative sign, so that's why you have this negative. And then for each of these, we need to evaluate f of pi/8, because it's expanded at pi/8. This a value is equal to pi/8. So f of pi/8 is sine of twice of pi/8, which is sine of pi/4, which is radical 2/2. F prime of pi/8 is twice of cosine of 2 times pi/8, and that's 2 times cosine of pi/4, which is 2 times radical 2/2. 2 cancels, and you get radical 2. And this one here, f double prime of pi/8, is negative 4 times sine of, same thing, 2 times pi/8 will be pi/4. And since sine pi/4 is radical 2/2, you get negative 4 times radical 2/2, and 4 divided by 2 is 2, so it's negative 2 radical 2. And we are almost done. Now we have that sine of 2x is equal to f of a, which is radical 2/2, f prime of a over 1 factorial. 1 factorial is just 1, so dividing by 1 factorial doesn't do anything, so we just put f prime of a, which is radical 2, x minus pi/8, plus, then if 2 factorial is 2, so we have to divide f double prime of a by 2. If we divide this by 2, you get negative radical 2, and then x minus pi/8 squared, and then plus more terms. So this will be the first three non-zero terms of the Taylor polynomial. How many terms are needed in order to approximate this with error less than 0.001? So we know that if I say the partial sum, if we define the partial sum as sigma n from 1 through capital N of negative 1 n plus 1, then the actual value, the actual value the difference between this actual value with the partial sum at n, because this is an alternating series, the alternating series is always, the error is always less than the next term. So a of n plus 1 is the maximum error between the partial sum, nth partial sum, with the actual value of the sum. So using this formula, we can say now that if I want this an plus 1 to be equal to, or actually less or equal to 0.001, let's see what that means. That means that since this is your an, if I replace n by capital N plus 1, I get -1. Actually, we need the, we just need this part, no. Actually, this just changes the sign, so we really need 1 over this. So that's your an. So it's 1 over square root of 2 capital N plus 1 plus 1. And that has to be less or equal to 0.001. Now, if we take the reciprocal of both sides, it's going to be, well, this is 2n plus 2 plus 1, so it's 2n plus 3. And you get 1 over 0.001, which is 1,000. And when you take the reciprocal of both sides, the inequality flips. And that means we have square root of 2n plus 3 greater or equal to 1,000. And if you square both sides, then you end up with 2n plus 3 greater or equal to 1 million. Subtract 3, which will be 999,997. Divide by 2, it's going to be, let's see, 49999. Let's see, 99993. So you have, okay, 0.5. Actually, 8.5, sorry. 8.5. So you need at least n equals to 49999. Okay. So that's the answer. We need this much in order to achieve error less than 0.001. Okay. Now, let's actually get to use that. See, when you try to approximate the value of sine x squared, you can't, you find that this is impossible to calculate because the antiderivative of sine does not exist. You can't integrate this using u substitution or integration by parts or any method that you know. This is one of those integrals where the antiderivative cannot be expressed by basic functions. Now, when this happens, you have two ways to figure out this integral. One will be to use something like Simpson's rule, because this, after all, this is an area. So you can do the approximation of the definite integral by using Simpson's rule. Another one would be to use the Taylor series of this. And actually, for this case, Taylor series provides a quite convenient way to express it. So if you rewrite the sine series, it's actually, so let's see, sine of x is x minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the fifth. And well, I guess it's easier to use the formula. Okay, so this is the Taylor series. I guess a lot of times people write this with a plus and start with 0. Okay, so that's the Taylor series. And then that means sine of x squared would be replacing this x by x squared. Which would give you this twice of 2n plus 1, so it's x to 4n plus 2. So you get sigma of n equals to 0 to infinity, and you have negative 1 to the nth power over 2n plus 1 factorial x to the 4n plus 2. And then you integrate this, it's going to give you sigma n from 0 to infinity of negative 1 to the nth power over, you add 1 to the exponent and put the reciprocal in front, 4n plus 3. And there's 2n plus 1 factorial, which we have. And then you plug in 1 and 0. So the series will end up being negative 1 to the nth power 4n plus 3 times 2n plus 1 factorial, and then just 1 plugged in. So when 1 is plugged in, that's gone. And when you plug in 0, there's nothing. So this will be really the series representing the value of this integral. Now, as you notice here, this is an alternating series, so we know that the value of the an plus 1, so an plus 1 is the error for the partial sum Sn, which means we have to just figure out when to get this. Well, I think there's really not much you can do except for some trial and error here. So if you have, let's see, this is really 1 out of 2,000. So you're trying to get 1 out of 2,000 here. And when, let's see, when n is equal to 3 maybe, that's 7 factorial. 7 factorial is 5080. Let's see, 5040. And then, oh, so already 7 factorial gives you 5040. So if you have 1 over 7 factorial, that'll be much smaller than 1 over 2000, right? What if you have n equals to 2? Then this part will give you 5 factorial, which is 120. 23 times 120. Oh, okay. So if n is 2, you're going to get a2 as 1 over 2 times 4 is 8. 8 plus 3 is 11. And then you get 5 factorial, which is 120. So it's only going to be 10320. And that's not good enough. It's still bigger than this. So it looks like you really need n equals to 3. So when n plus 1, so what I'm trying to say is that a3, because of this fact, we know that a3 is less than 0.005. Which means you only have to do S of 2. S of 2 will be a good enough approximation that's accurate to 0.0005. Amazing. You just need 2 terms. Okay, so when, oh, actually, S of 2 is 3 terms because n starts from 0. Okay, so starting from 0, when n is 0, you get positive 1 and 3 there, and then 1 factorial. So 1/3 is what you get when n is 0. This is a0. a1 would be 1 over 7, and then 3 factorial is 6. 6 times 7 is 42. And then we just did a2, which is 1 over 1320. So that's the approximate value. If you insist, you can make it as a single fraction, but I guess you can just put this into your calculator and figure out what that value is. So you can use your calculator. For me, I'll just use Python. Console 1/3 plus 1 over 42 plus 1 divided by 1320 is going to give me about 0.3579. So that's the approximate value. So this is about 0.3579, and then actually, because the accurate approximate value has the error of 0.0005, the last bit is not really correct, so it should be about 0.358. That's how you should say it, because if you go one further, then it's more than the accuracy that we have set. Okay. Find the Taylor series of the given order M n centered at C. Okay, so what this is saying, that it's requiring you to find the Taylor series centered at 1. Remember that the Taylor series formula is f of c. Sometimes I write f of a, but c is okay too. C is also widely used. X minus c x minus c squared. So this is the formula for the Taylor series, and since it's asking for a second order polynomial, it's asking for me to get this much. Okay, so this much is called the Taylor polynomial rather than the Taylor series. So what is the Taylor polynomial with c equal to 1? Well, that requires me to find f of x, which is e to the x, f prime of x, which is, actually, f of x is x times e to the x, right? F prime of x is the derivative of this, which is x times e to the x. If I differentiate e to the x, it's still e to the x, but if I differentiate x, that's 1, which gives me x plus 1 e to the x. F double prime of x would be the derivative of this. Again, using the product rule, you're going to get x plus 2 e to the x. Now from these values, we have to evaluate f of 1, because c is 1 in here, and c is 1. F of 1 is just 1 times e to the first power, which is just e. This is f prime of 1, which is 2 times e to the first power. That's 2e. F double prime of 1 will give you 3e. So we are almost there. F of x, which is x to the e to the x. This is similar to the Taylor polynomial. F of 1, which is e, plus 2e over 1 factorial. So that's just 2e. And then x minus 1 plus f double prime of c over 2. So it's 3 over 2e. It's 3e over 2, because you have to divide by 2 factorial. And then x minus 1 squared. Okay, so that's the Taylor polynomial. Let's try the second one. You have f of x, and since we're looking for the third order, we need to find the three derivatives. F prime of x is negative sine of x. F double prime of x is negative cosine of x. And f triple prime of x is positive sine of x. And from there, we know that f of pi over 3, f of pi over 3 is cosine pi over 3 plus 1, which is 1/2 plus 1, which is 3 over 2. F prime of pi over 3 is negative sine of pi over 3, which is radical 3 over 2 with a minus. F double prime of pi over 3 will give you negative cosine pi over 3, which is negative 1/2. And f triple prime of pi over 3 gives you sine of pi over 3, which is radical 3 over 2. And therefore you have, using the Taylor series, you have cosine of x plus 1 is similar to, approximately equal to 3 over 2 plus negative radical 3 over 2 x minus pi over 3 remember it's f prime divided by 1 factorial. The next one, which is negative 1/2, that's divided by 2, x minus pi over 3 squared. And the third one, that's divided by 3 factorial, which is 6. So you have to divide by 6, radical 3 over 2, x minus pi over 3 cubed. That's the Taylor polynomial for cosine x plus 1. Degree 3, centered at pi over 3. Find the Maclaurin series for the sine integral function. So what's the sine integral function? This is defined as the integral of the sinc function. This thing inside here is called the sinc function. Now, this is well known to be not integrable using basic functions. That's why when you integrate it, then you have something that's not defined properly. You can't define it using any basic functions. Okay, so what physicists ended up doing is that because they really need this function, they just named it as sine integral function. Okay, so this is not a typo. I'm not trying to write sin. This is just si of x. Such a function does exist. Okay, so how do we do this? Well, it's an integral from 0 to x of 1 over t times the sine of t, and sine of t has the following Maclaurin series, which is negative 1 to the nth power over 2n plus 1 factorial x to the 2n plus 1. Oh, but it's not x because it's in t, so we should be using t there instead of x. T dt. And then when 1 over t is multiplied in there, then we end up with 0 to x sigma n equals to 0 to infinity of negative 1 to the n over 2n plus 1 factorial times t to the 2n dt. So now we integrate this. These are just constant multiples, so we're really just integrating t to the 2n, which is t, you add 1 to the 2n, put the reciprocal in front, and then sigma n from 0 to infinity of negative 1 to the nth power 2n plus 1 factorial. And then you have integral from, actually this is already integrated, so we don't put integrals anymore, and then we have to put x and 0. So when you plug in x into t, all it does is it replaces t by x. When you plug in 0, it doesn't give you anything, it's just 0. So what you end up with is sigma, that's equal to sigma n equals to 0 to infinity of negative 1 to the nth power over 2n plus 1 factorial, then times 2n plus 1, and then you have t to the 2n plus 1. X to the 2n plus 1. And that's it. That's the Maclaurin series for the sine integral function. Find the geometric power series of the function. Okay. Oh, there's an f missing here. So here, what you're trying to do is you want to know how to use a over 1 minus r, which is a plus ar squared ar cubed plus da da da. You want to be able to use this formula to come up with some kind of a power series. Now if you compare this with that, I guess a is 4, but you have 1 here and there's 3 there, right? So how do you change that? Well, you do 4 over 1 minus negative 2 minus x, and so that's what f is equal to, right? 3 is 1 minus negative 2, so that 1 and 1 is the same. So what is r really? R should be something like this. So let's see if we rewrite it as 1 minus negative 2 plus x, right? If I factor the negative out, that's what we get, and now it's perfect. A is 4, 1 is 1, r is negative 2 plus x. And therefore, I can just use the formula on the right side, which says 4 plus 4 times x minus 2. Let's just rewrite this as x minus 2. And then plus 4 times x minus 2 squared, plus 4 times x minus 2 cubed, and so on and so on. Wait, what is this? This is a Taylor series centered at 2, right? So this is indeed the question that's being asked. Now let's try to do the second one. In this case, if we try to use a over 1 minus r and say, oh, it's 2, so it's 2 is equal, 2 minus x is equal to 1 minus negative 1 plus x. Actually, yeah, plus x. If you do that, then you end up with 1 minus x minus 1, so that's your r value. If that's your r value, this is the one that gets squared and cubed and all that. So you're going to end up with a Taylor series centered at 1, which is not what you want. You want something to be centered at 0. So you need to change this in a different way. So what other methods are there? Well, instead of trying to break 2 as 1 plus 1, another way to do this would be divide 2 top and bottom. Then you get g of x equal to x cubed divided by 2. 2 divided by 2 is 1. X divided by 2 is x over 2. And now you do have 1 and 1 matching, so r is x over 2, and x cubed over 2 is your a. So that means x cubed over 2 is the first one, and then plus x cubed over 2 times x over 2 plus x cubed over 2 times x over 2 to the second power, and so on and so on. Now if you look at the pattern, the pattern actually is there. It's really like it's 3, 4, 5, so n starts from 3, right? And then when n is 3, you get just 2, and when n is 4, you get 2 squared. When n is 5, you get 2 to the cubed. So the power of 2 actually is 2 less than this n value, so it's n minus 2 there, and then 1. So this is actually the geometric series centered at 0. Okay. Finally, this one. Now this actually looks very horrible. At some point you're totally lost. What is this, right? But here's another way to look at it. If c is negative 3, if c is negative 3, that means we have x minus c, which means x plus 3. See, x minus negative 3. If c is negative 3, x minus c will be x minus negative 3, which is x plus 3. That means I need to express everything as x plus 3, which is good for the top one. That's expressed as x plus 3. And for 5x, we need to rewrite x plus 3 over 5x plus 4 as x plus 3 over 5 times x plus 3 plus something here. Okay, let's think about what goes in here. 5 times 3 is 15. 15 minus 11 gives you 4. So this should be really minus 11. Okay. Now, you can put a minus in front and make the denominator to change places. So instead of 5x plus 3 minus 11, you want to write it as 11 minus 5 times x plus 3. And then you have x plus 3. Then to use a over 1 minus r equal to sigma n from 1 through infinity of a times r n minus 1, to use this formula over here, you see that you should be dividing top and bottom by 11. so that you have negative a is x plus 3 over 11, whereas your r would be this much, right? It would be 5 over 11 x plus 3 to the n minus 1. N from 1 through infinity. And that's equal to, actually this entire thing is taken to the n minus 1 power. So you're going to get negative of 5 to the n minus 1 power over 11 to the n minus 1, but there's another 11 here, so it'll be 11 to the n. And x plus 3 to the n minus 1, but there's another x plus 3, so if you multiply these two together, it's going to be x plus 3 to the nth power, and you have sigma n from 1 through infinity. So that's how you do it.